As you guys can read, 1.10 is all about writing linear equations. I mean, the whole unit 1 is about algebra review. And it seems like a weird thing to do. Because if you think about the previous stuff we reviewed solving equations, which, yeah, you did that in Algebra 1 and Algebra 2, but it definitely is something you do in future math classes. We reviewed rational expressions, which, yeah, you did in Algebra 1 and Algebra 2, but you definitely do that in future math classes. Writing linear equations, though, that seems like a childish thing to do. It doesn't seem like high-level math stuff. I mean, this is pre-calculus. I'm supposed to prepare you for calculus. Why do we, spend time talking about writing equations, linear equations? Well, believe it or not, of all of the review topics we've done, this is the most closely related to calculus. How does linear equations relate to calculus? You don't have to write anything down. You don't have to copy these graphs. I just want to show you guys a couple of pictures to sort of hopefully get the point across. So what does calculus have to do with linear equations? Well, here's the calculus idea. No matter what function you're dealing with, polynomials, rationals, trig, for example, right? There are lots of squiggles. Would you agree that this is not a line? It's lots of turns, lots of ups and downs. But here's this calculus idea. This is what calculus does. Calculus does not look at the big picture, but instead looks at the small picture. So if we were to look at a portion of this graph, say to the bottom left corner, bottom left of 0. I can't mark on Desmos, so we're gonna have to use verbal cues. But if we focus on the bottom left of 0, see how it sort of twists and turns there. It's still curvy, but if you zoom in far enough, what does he look like to you? Linear, looks like a line. Well, polynomials, they're simple functions, right? It can't be true if you have something complex like a rational function. Let's take a look at the to the left of 0, this bend here, because this really curves out. Well, it's still curvy, but if you zoom in close enough, it looks like a line. Well, surely it can't happen with trig. Trig is high-level, complicated stuff. Let's take a look at one of these peaks here, or this peak right here. Curvy, I'm zoomed in a lot. Still curvy, but if I zoom in just enough, if you keep zooming in, it looks like a straight line. And that is a calculus idea, that every single function doesn't have to be polynomial. It could work for square roots. It could work for logarithms. Every single function can be thought of as a collection of an infinite amount of infinitesimally small line segments. Well, if every single function can be broken down into line segments, it sort of makes sense that we need to be able to write an equation of a line. So that's why I think that this section is in our review section, because writing an equation of a line is as important, if not more important, than, say, solving an equation when it comes to Calculus 1. So what are some Algebra 1 and Algebra 2 ideas that you need to have? So these are sort of like prerequisite knowledge. Prerequisite is just a fancy word for saying like prior knowledge, stuff you need to know. Actually, I don't think it's hyphenated, so I probably wrote it wrong. Anyway. When it comes to linear equations, we definitely need to know slope. Right. If you took Algebra 1 in this country, your Algebra 1 teacher probably used these terms. Rise over run. That's what slope is. Then you graduated to Algebra 2, and your Algebra 2 teacher probably used these fancy symbols. Triangle y over triangle x. The triangle is pronounced delta, by the way, so your Algebra 2 teacher probably said, hey, slope is just delta y over delta x. The change in x, or change in y over the change in x. And of course, in either Algebra 1 or Algebra 2, your teacher probably gave you this formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's what those delta really means. Anytime you have delta in math, it just means the second one minus the first one. So we definitely need to know the slope formula in order to write linear equations. We have to know that lines are sort of defined by their slopes. We could have lines that have positive slopes. So lines with positive slopes go up and to the right. You can have lines with negative slopes. They go down to the right. Most lines fit in one of these two categories, but we do have what I personally call special lines. You have lines that are perfectly flat or horizontal. These guys here have a zero slope. Some textbooks, some teachers call them no slope. And I'm not a big fan of that because no slope implies that you just don't have one, which is false. He does have a slope. It's a slope of 0. So I, Mr. Vo, does not use this term, but your textbooks, your future teachers might use it, so just know that. And we have perfectly vertical lines that have undefined slopes. Yeah. Now, I call these guys special lines because they have a special way of writing them. They don't fit the linear equation mold. All horizontal lines, all zero slope lines are written as follows. Y equals some number. Y equals 2 is an example of a horizontal line. Y equals negative 1.7 is a horizontal line. Undefined slopes have a special way of writing them. They're always x equals some number. X equals 5 is a vertical line. X equals negative 3/2 is a vertical line. If your line is not special, perfectly flat or perfectly vertical, they most likely will come in one of these various forms. There are lots of different ways to write linear equations. We have the tried and true gold standard slope-intercept form. This is the format that you see in the backgrounds on chalkboards of movies that want to look all mathy, but they don't really know what they're doing. It's the standard y equals mx plus b, right? That's the tried and true. Everyone loves it. Why do mathematicians call it slope-intercept form? Because that's exactly what it tells you. The m here is your slope, and the b is your y-intercept. It will get the job done. You can write any linear equation in slope-intercept form, using slope-intercept form as well. My personal favorite, however, and of course I always like to inject my biasness, is point-slope form. So when I personally, Mr. Vo, on his free time for fun, write linear equations, this is the format I use. Y minus y sub 1 equals m times quantity x minus x sub 1. And as the name suggests, it gives you information or utilizes information involving the slope and a point. Again, m is your slope. In this case, the y sub 1 and the x sub 1, that is your point. In point-slope form, the regular y and the regular x will always stay as variables. One of these two forms is the forms I would suggest we use when it comes to writing linear equations. Technically, there are two other forms, and I will include them for the completeness of our notes, but we won't use them to come up with equations. They are standard form, these equations look like some number times x plus some number times y equals some number c. So standard form has the variables on one side and the numbers on the other. There's also general form, which is closely related. They have everything on one side and 0 on the other. So these guys look like ax plus by plus c equals 0. In either standard or general form, it is important that the coefficients a and b and the constant c are all integers. That is to say, positive and negative whole numbers. Standard form and general form does have its uses. It looks cleaner, looks nicer. There's no fractions, but it's sort of useless in terms of doing stuff. Slope-intercept form, it gives me the slope and the y-intercept. Point-slope form gives me a point and slope. Standard form and general form, they just stand there and look pretty, which I suppose in this world has some uses, but not in mathematics. So we're primarily going to stick with the left side here when it comes to writing an equation. Now, as you guys can see in the agenda, we have 4 different example types to talk about. Here's the main idea. Here's the big idea. You only have one example type. All 4 of those, although they look different, boil down to the same thing. So let's run through the order. The first one is sort of a trivial example. When I say trivial, I mean it's super duper easy. Now, I've been teaching this for as long as I can remember. Every single year, I always have one person get these types of questions wrong in the test. Don't be that one person. Otherwise, I'll laugh at you. No. I mean, I may laugh at you for other reasons, but I'll laugh at you some more for this. So the equation. Write an equation of a line that has a slope of, I don't know, -7/4 and a y-intercept of -2. Right, making it up. Geez. They give me information of slope. They give me information of y-intercept. We have slope-intercept form. Maybe I should use it to write an equation. So to answer this question, we use slope-intercept form, y equals mx plus b. Gee whiz, the m is the slope, the b is the y-intercept. Guess what? Just plug and chug, you're done. My answer is y equals the slope of -7/4. And since my y-intercept was negative instead of plus, I'm going to put a minus. That is the answer. That is the equation of that line. And it's almost guaranteed that I always get at least one student get this question wrong on the test. Question?
Well, why did you get rid of the x?
Oh, x. Thank you. Yeah.
Sir, you got it wrong.
Yes, I did get it wrong. My whole life is a laughing stock, so I'm already laughing.
Oh, sorry. Not mean to bring that up.
So don't be that one person on Thursday that gets this one wrong. This basically, I'm giving you free points by putting this on the test. So this is a trivial example. Let's talk about a non-trivial example, something that we actually have to do a little bit of work. Not a lot, just a little bit of work. I'm also lazy, guys. Every single instruction on these examples will be write an equation of a line that blah, 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 blah. I'm not going to be writing it over and over and over again. So ... that just means it's the same instructions. So blah, 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 write an equation of a line that has a slope of -1/2 and goes through 4, -3. Right. This is what you most likely face in a non-trivial example. They give you a slope and they give you 1 point. Again, if you look at the agenda, all those different example types, every single one of them will boil down to this example type here, a point and a slope. That's the bare minimum information you need. So how do we approach this? Well, most students like to go back to their tried and true form, y equals mx plus b, and that will totally work. Y equals mx plus b. The only thing different in this case is they give me information about the m, and a point, you have to remember that all coordinates are an x value, comma, a y value. So they give you information about the y and the x. They do not give you any information about the b, the y-intercept, so you have to solve for it. So just plug everything in. Y is -3 equals m is -1/2, x is a 4. They do not give me a b, so I leave it as a variable. So you just do math. -3 equals -1/2 times 4 is -2. And I hope everyone can see that to solve for b, I have to add 2 to both sides. Adding 2 gives me -1 equals b. Right. Now, again, I've been doing this for a while, and I know that if you're going to make a mistake, I'm not saying you will, if you're going to make a mistake, this is where you do it. Kids, on quizzes and tests, you guys get so stressed and like super focused. It's sort of like you put blinders on, you have tunnel vision. You go, okay, I just did a whole bunch of math. I got an answer. That's it, and I move on. Right? All you did was solve for y-intercept. You did not answer the question. So just take it slow and steady on Thursday. answer the question. If I'm going to ask for an equation, you better give me an equation. So all you have to do is put that y-intercept back into slope-intercept form. Y equals negative 1/2 x minus 1. That would be the answer I'm looking for. So just remember on Thursday, don't stop at the y-intercept. Give me the full equation as your answer. So that's basically it. Every single example we're going to do today, and what you guys will do in the practice, will be some variation of this problem. Now, that's using y equals mx plus b, slope-intercept form. I actually like point slope form, and since, I'm the teacher, I'm going to show it. Y minus y sub 1 equals m times x minus x sub 1. The reason why I like this format is when you're done, when you solve it, when you're done, you're done. There's no back substitution. There's no way to make a mistake. Just as a reminder, m, of course, is your slope. Your point are the x's and y's that have the subscript. In point slope form, the regular x and the regular y stay as variables. So let's do this really quickly. Y minus a negative 3, that's your y, equals my slope was negative 1/2, x minus a 4. Get into the habit of using parentheses when you substitute. It lets you see those double negatives. So we get y plus 3 equals, distribute the negative 1/2, negative 1/2 x, and a negative 1/2 times a minus 4 is a positive, 1/2 times 4 is 2. And then we want to solve for y, subtract 3 from both sides, you get y equals negative 1/2 x minus 1. So you can see you get the same answer either way. But the reason why I like point slope form is once you're done, I know that's my answer. So pick your poison. I don't care which method you use, slope-intercept form on the left, point slope form on the right, as long as you get the same equation. Okay? For the notes, though, I'm going to be showing the right method because I like it. That's it. If you understood that example in and out, you can teach it to someone. Congratulations. You are a master at writing linear equation. I don't care if this is an Algebra 1 class. I don't care if this is Calculus 3 class. If you ever need to write an equation line in any situation, you're doing that. Sure, the problem might be, quote, harder because you hide the information, but ultimately to write a linear equation, you need 1 point and 1 slope. Let's take a look at this example here. So that's the only way I can make this harder, which I'm not saying it's hard to begin with, is if I don't give you all the information up front and I hide it. So ... write an equation of a line that yada 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 goes through negative 1 comma 2 and 3 comma negative 4. Recall that in order to write a linear equation, you need a point and a slope. In this example, they give you plenty of points. Yay! In this example, though, they don't spoon feed you the slope. So that should trigger in your mind, that should tell you as a student, okay, this is a writing an equation problem, but they don't give me a slope. I need to hunt for the slope. Look at what you have. I need a slope. I have 2 points. Gee whiz, can I find a slope given 2 points? Yes, you can. So that's basically it. That's the only reason why this is, quote, harder. You just have to do a little bit of extra work to find your slope. Just to refresh your memories, it doesn't matter which one's the first point and the second point as long as you're consistent. I'm just going to go in order. Right? The first one's x1s, the second ones are the 2s. So just plug everything in and you're basically home free. Y sub 2 is negative 4 minus y sub 1 is 2 over x sub 2 is 3 minus x sub 1 is negative 1. Use parentheses when you substitute. It'll save your life. Negative 6 over 4, which reduces to negative 3/2. Look at what we have now. We have a slope. We have plenty of points to choose from. Gee whiz. That was just like the previous example, a point and a slope. We do have an abundance of points. It really doesn't matter which one we pick. You guys have a preference, the first point and the second point? The first one. Sorry, he beat you to it. The first point. Got to be faster with the suggestions. So if in your notes, if you want to use the second point, go ahead. We should get the same equation. So y minus y sub 1 equals m times x minus x sub 1. You guys get the idea? Can I fast forward through this? All right. So I'm going to blaze through this, but you guys know all I'm doing is I'm substituting and solving for y. So my point was, I scrolled up. Y sub 1 was 2 equals m was negative 3 halves. X minus x was negative 1. Y minus 2 equals, distributes, negative 3 halves x. And this is where using parentheses to substitute will save your life here. So I know I have a minus minus right here, which makes it a plus, but then I'm distributing a negative, so a positive times a negative ends up being a negative again. And then 3 halves times 1 is 3 halves. Right? And then all that's left to do to solve for y is add 2. Now I hate to say it, you may get some fractions here. This is pre-calculus. We got to get comfortable with fractions. So if you aren't comfortable with fractions, well, get to being comfortable with it, or just use a calculator. So we have negative 3 halves plus 2, which is negative 3 halves plus 4 halves, which is positive 1 half. Y equals negative 3 halves x plus 1 half. Should be the equation. Okay. So I could hide the information by giving you 2 points instead of outright giving your slope. Well, that just means you have extra work to do. Okay? Right. How can I make this even harder still? Well, I could bury the information behind another equation. So some more prerequisite things that we need to know. Recollection, recall. And this is actually a geometry thing. Two distinct lines that are parallel have the same slope. And what I want us to sort of like make a mental bridge, make a mental connection is anytime I think of parallel, I think of same slope. Parallel means same slope. Okay. And you guys can probably guess what the other recollection is. Two lines are perpendicular. This is a C, not an L. Now, this is pre-calculus. The higher in math you go, the more fancy the words become. AKA, the following two words are equivalent to perpendicular. They may use the word normal. So if your line is normal, that means you're perpendicular. Or here's a $5 word. Orthogonal. All three of those terms mean the same thing. Perpendicular, normal, orthogonal. They just mean they cross at 90 degrees. So two lines are perpendicular if they have opposite and reciprocal slopes. So the mental bridge, mental trigger, the mental connection I want you guys to make is every single time you think of perpendicular, you're thinking of opposite and reciprocal. Perpendicular means opposite and reciprocal. Right. Let's do an example. And this example, when I pre-made it, normally I do one example of parallel, one example of perpendicular. I felt lazy. I'm going to blend them together. So we're going to kill two birds with one stone here. Dot, 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 write an equation of a line, that yada, yada, yada. Goes through 5, 2. And is. Here's the killing two birds with one stone. Part A. Parallel to. Or part B. Perpendicular to this equation, 4x plus 6y plus 5 equals 0. Okay. So basically one problem, but we're going to do both, the parallel and the perpendicular one. So again, any writing an equation problem, you need to have two things: a point and a slope. In this problem, they gave us the point, 5, 2. I'm happy. In this problem, gosh darn it, they did not give me my slope, which means I need to do extra work to find it. The only thing they gave me was this equation here and the idea of parallel and perpendicular. So let's just go ahead and run through the solution. We'll do the solution of A first. So part A asks for a parallel line. Hey, the word parallel in our brain should trigger same slope. So I need this guy's slope. Now, he's given to us in general form. Look how nice and pretty and neat that is. No fractions, no ugly numbers. But it's utterly useless to me because I don't know what this guy's slope is. So the first thing I need to do is set it to slope-intercept form, solving for y. I hope by now, after all of our solving review, we know how to do this. I'm going to do 2 steps at once. Let's subtract the 4x and let's subtract the 5 at the same time. So you get 6y equals negative 4x minus 5. And then lastly, divide everything by 6. Y equals negative 46x minus 5 over 6. That is an ugly equation. That's why we use general form. It makes things pretty. Has fractions everywhere, a fraction y-intercept. But I don't care. I don't care about the y-intercept. According to my need to have, all I care about is the slope. And here's a slope here, right? Which I'm going to reduce. So all of this work tells me their slope is negative 2/3. I just reduced them. My problem wants parallel, which triggers in my brain same slope, which means our slope should be the same, negative 2/3. By the way, other class parents ask, hey, Mr. Vo, do I have to do all this writing when I do my... No, I'm only doing this for the notes. Obviously, their slope, parallel, our slope thing, you would do it mentally in your brain. Right. So that's it. We have a slope. It goes back to the earlier example. We have a slope. We have a point. Can you write an equation? And I hope the answer is yes. Right. You guys okay with that idea? Okay, I'm going to blaze through the exam. I'm going to blaze through it because, again, it's just plugging stuff in. So y minus y sub 1 equals m times x minus x sub 1. I think the point was 5, 2. So it was y minus 2 equals negative 2/3 x minus 5. Distribute the slope. Y minus 2 equals negative 2/3 x. Negative times a negative is a positive, and 2/3 times 5 is 10/3. And then finally add 2 to both sides. You get y equals negative 2/3 x plus 16/3. That is the equation of that line. This line is guaranteed to be parallel to the previous line and go through this point. Okay. Easy peasy. That was parallel. What if I change the instructions to perpendicular? All of this work that we did in solution A, if I change the problem to perpendicular, all of this stuff here stays the same. You literally do the same thing. The only thing that will be different is your logic. So for the solution to part B, I'm going to start right here. So solution to B. We know that their slope was, what was it, negative 2/3? We wanted perpendicular, which triggers in my mind opposite and reciprocal, which means our slope should be the opposite sign. So instead of negative, be positive, and then the reciprocal, which is 3/2. That's it. That's the only difference. Then you just become a robot, write an equation of a line, given this point and that slope. So again, the point was 5, 2. I'm going to use point slope form, but you guys use whatever you want that's comfortable to you. Y minus 2 equals m is 3/2. X minus x sub 1 is 5. distribute. Y minus 2 equals 3 halves x. Positive times a negative is a negative. 3 halves times 5 is 15 halves. And adding 2 to both sides gives us y equals 3 halves x minus 11 halves. Right? That line is guaranteed to be perpendicular to the original line and guaranteed to go through this point. So that's a pretty neat thing that we did 4 different example types, but they're basically the same problem. And I promise you, when you write equations of lines in calculus, Calc 1 next year, it's the same thing. We're basically doing a calc problem right now, just without the calculus logic. Pretty neat idea. Okie dokie? Okay. The last thing I need to cover, though, are those special examples, those special cases. So everything we've done so far have been regular lines, but what about parallel? What about horizontal and vertical lines? So here's my red flag I'm waving. Warning, disclaimer. I am not trying to trick you. It is a simple, logical, straightforward question. Assuming that my drawing skills are perfect, this is a perfectly vertical line. What type of lines are parallel to vertical lines?
Say it again.
What type of lines are parallel to vertical lines? Other vertical lines, right? Yeah, not a trick question. Right. Vertical line. What type of lines are perpendicular to it? Horizontal. So perpendicular to horizontal. And then we can run the same logic for horizontal lines. Horizontals are parallel to horizontals, and horizontals are perpendicular to verticals. So if I ever give you a parallel perpendicular line and I give you one of those special lines, you have 0 calculations to do. It's all pure logic. And remember, vertical lines look like x equaling a number. Horizontal lines look like y equals a number. Right? So next to the very first example we've done, these should be freebie, gimme, automatic free points on the test. Don't mess them up. For example, yada, 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 write an equation of line that goes through. Give me your second favorite point, not your first one. We don't want to waste your first favorite point. 8, comma, let's be fancy, -2. And is parallel perpendicular? Parallel, I heard first. Parallel to your favorite axes compared to the x or the y. Y-axis. So write an equation of a line that goes through that point and is parallel to the y-axis. Well, hey, y-axis, visualize it. Draw a coordinate grid. What type of line is the y-axis? Vertical line. And we want parallel. What type of line is parallel to a vertical line? Another vertical line. What do equations of vertical lines look like? X equals a number. They gave you this point, red flag, disclaimer. It's not a trick question. Very obvious, straightforward. Every single point is an x comma y. We know that our answer should be x equals a number. Guess what our equation should look like? X equals 8. That is the answer. X equals 8. Because it's a special line, it has to go through that point, so clearly the x value has to be 8. Okay. So I usually put 1 or 2 of these problems on the quiz. They should be like freebie points. Don't mess it up. Okay. But that's it. That's all you need to know about writing linear equations.